Hey, this is Kevin from kevinsguides.com and welcome to the second video on Simple Pong. In this video, we're going to be extending on the capability of the previous lesson where we created a basic Pong application. We're going to be adding a few additional features such as better AI or better PC paddle detection logic and movement, and we're also going to try to just overall make the game feel a bit more realistic and better. So as it stands, if we open up the game of Pong that we've created and we run that, we have the PC paddle on the right, and that is just tracking the Y position of the ball and trying to line up with it. And that works fine for the first few rounds, but once the ball starts picking up in speed, the PC has no way of predicting where the ball is actually going to go, and it cannot move to the right location at the proper speed. And we see that happen here, and it will miss on that third or fourth bounce every single time the way it's currently set up. So that's not a ton of fun. We want the PC to be a bit more intelligent and to be able to predict where that ball is going to go without having to increase its speed. Make the game a bit more even on both sides here. So I would start by copying the project files from the last project over to a new folder and just opening that up so we have a fresh working copy ready to go. And let's talk a little bit about how we're going to predict that ball's location. Now, right now, the ball just moves in a set direction. It bounces off the paddle and always just reverses depending on which way it bounces from. It's just a change in y. The cy, and cx variables are just always swapped, so we know exactly where the ball is going to go. But we could write like an equation for a line and try to predict where the ball is going to end up on the right side each time. But I think rather than making complex math equations and things like that, an easier way to predict where that ball is going is just to create a second ball. And it will be invisible in the end, but we'll create a second ball and this will move a few steps ahead of the regular ball and track where it's going to go. So by the time our game ball gets to, say, here, maybe our future ball has already bounced off, bounced off, bounced off, bounced off, and now we know, where it's going to hit over here on the right. So the future ball moves ahead of the game ball, and that predicts the position that it's going to hit. So once we know where our future ball or our prediction ball is going over the x variable or the x value of the PC paddle, so once it goes past this point, we just take the y value of that future ball and we tell our paddle to move up or down in the direction of that future ball. Let's start by going to the Pong game class, and here we have private ball game ball. Let's begin by just initializing a new or declaring a new variable, and we'll call that future ball. Okay. So we have game ball and future ball, and again, future ball is just running a few steps ahead game ball, so we can tell where the game ball is ultimately going to impact the right side of the screen. And when we initialize this guy, we want the future ball to always start, like whenever the game resets or something major happens in the game, we basically want the future ball to reset and just be a copy of game ball initially before we start advancing it those steps out in advance. And the easiest way to make future ball a copy of game ball is with a copy constructor. And copy constructors are just constructors that take the same object type as their argument or parameter and make a copy of it. So we'll have our copy constructor and it will take a ball B as the argument, and just here to say copy constructor The ball being copied is the parameter. And then all we have to do is copy all of this, paste it in here, except instead of this dot x equals x, it's just this dot x equals b dot x, b dot y, b dot cx, b dot cy, b dot speed, b dot color, and b dot size. So that is a copy constructor for a ball. Now to make the second ball that since we only have two balls right now, our game ball is yellow. I want to make the copied ball a different color just so we can see the difference here. So I'm going to go with color magenta here and just make the copied ball, which is going to be the future ball in a second. That'll be magenta. At the end of the program, we're going to make that future ball invisible, but for testing, it will be useful to have it on the screen and to be a different color than the regular ball. So we have future ball equals new ball, and then we just pass in game ball under the Pong game constructor. And that creates a copy of our game ball in future ball. We might as well paint that future ball as well. So in the Pong game is paint component method. Let's put this at the very end of the paint component method so it kind of paints that test ball, paint the future ball, and then we hit the to do like remove later. So we have future ball dot, and we just paint it the same way we painted the original ball by passing it that graphics G object. And now let's just see what happens when we run the program. We can see that the future ball is there in the center. We didn't put any move logic in for it yet, so it's not really doing anything. But it exists, and that is the important thing. Alright, bear with me here. The next thing I want to do is start advancing the position of that future ball. And in order to do that, we're going to have to make some changes to our game's logic. Now we want the future ball to behave in the exact same way that the game ball behaves, but we want it to assume that it always hits the left paddle, so it always hits that user paddle. Even if it's really not going to, like the user just misses, we just always assume it bounces off the left side, and then we want to find again that point where it collides on the right side. So we want it to do all the same things like reverse X and bounce off edges and advance by one position every time the frame goes. But we want to do that until we find that collision point on the right side of the screen. So let's go back and create a new instance variable of type integer, and this is just going to be called detected collide y. And all this variable is going to do is keep track of the y position where we think the ball is going to next collide on the right side of the screen on the PC paddle side of the screen. So this will be the y position that the PC paddle ultimately needs to move towards. And then when that is first initialized, or when we first create a Pong game, we want to set detected collide y to -1 in the constructor there. And let's go to the reset method too. We might as well, when the game resets, we will also set that detected collide y to -1. And we need to reset the game ball or the future ball too. So the future ball equals new ball, game ball. So we reset future ball and the detected collide y in the reset method. Now let's work on advancing the position of future ball in game logic and advance future ball and figure out detected collide y, or detect collide y, whatever I called that. In order to do this, well, first let's see if detected collide y is equal to -1. So if we haven't found out where it's going to collide next, then this is where we want to move some steps ahead. And we can do that with a simple for loop. So for integer I is equal to 0, I is less than. I'm just going to advance it by 10 steps, but we could do more if we wanted. So every time our game ball moves 1 pixel or 1 unit in whatever the direction it's going at its speed, I'm going to advance the Pong game or the future ball 10 steps ahead. And in order to do that, we can do future ball dot, we'll call that move ball method just like we did with the game ball, and we'll also call future balls bounce off edges just like we did with the game ball. So that is moving in the same exact direction that the future ball did, right? So we advance the future ball. And the next thing we want to do is make sure every time this runs, we want to make sure we handle our bouncing off the user's paddle on the left side of the screen. Okay, at this point we have the change in X and the change in Y taken care of. We also have the bounce off the top and bottom of the screen taken care of. The next thing we want to handle is that bouncing off the left side. So since this is the future ball, I always want it to bounce off the paddle, or assume it's going to bounce off the paddle. So my logic is going to be similar. Remember, we have the reverse X method that we used last time. We're still going to use that. But for our future ball, we just want to check if the X position of future ball, so if our X of the future ball, we want to see if that makes it to this spot right here. Back in code here, we want to see if the future ball collides with the X position of the right side of user paddle. And before we can do that, we'll have to actually go to the paddle class. And if you don't already have one, we need to have a getter for that X variable. So public integer get X, and that just returns X in the paddle class. Back to Pong game, we can start doing our logic with that if there. So if the future ball, the X position of the future ball is less than, so if it goes over the left side of the user paddle, the X value of that plus the paddle's width, and we have the paddle width constant available, so I just called the paddle class paddle width there. And that should mean that we have gone beyond the right edge of the user's paddle. And then all we do is reverse the X direction of the future ball. Okay, now let's run this real quick and just see what happens. So hopefully you saw that it just bounced right off the bottom and then the right side of the screen. So we know that the first part works. And since I haven't put in any logic for finding like the next position or anything like that, and we haven't even gotten the paddle down to where it's supposed to go quite yet, with that future ball, we're not really doing anything with it yet. It just bounces off the right, and that's fine for now. But at least we know it's moving like it's supposed to. And the next thing we need to do is find that detected collide Y. So the collision point of that future ball. And this works just like pretty much the opposite of what we did there. So if the future ball get X, if that goes beyond or above the PC paddle's X position, and since again the X position is the left side of the paddle, that's the side we're looking for the PC paddle. So if the future ball get X is above PC paddle get X, then at that point we know we have gone beyond the paddle. And that means we know what the detected collide Y is. And in this case, that detected collide Y is just equal to the future ball's current Y position. So future ball.get Y. We need to make sure too that once we find this detected collide Y, we don't keep advancing the position of future ball. Because remember, this loop's set to go through 10 times. but say it finds this the fifth iteration of that loop. We don't want it to continue, so we just want to break out of the loop at that point and end that. So we have our detected collide y. We can also put a just for testing here, like a print line, say found y position for collision at detected collide y. So we'll just print that out to the console. And let's see what happens now if I run the program. Okay, perfect. So we see that right where the ball just hit the paddle, it is the same location that the prediction ball, the future ball, went to. So right there on the bottom right. And as well, the reset method was clearly working since I just missed that and the future ball went back to where it was supposed to go. So now instead of having the PC paddle move towards the game ball's current Y position, let's have it move towards whatever detected collide Y is. I just change that. And then finally, we need to handle what happens after the ball does actually collide with the PC paddle. We need to then calculate the next location that the future ball is going to need to go to. So after it collides with the PC's paddle, where's the logic for this? So if PC paddle check collision game ball, this is where it collides with the right side, and this is the point where we can set the detected collide y back to -1, since we don't know where the next location is yet. And we might as well just make or reinitialize the future ball 2 here. Future ball equals new ball, game ball. All right, do we need to do anything else here? I don't think so. Let's just run that and see what happens. So when my game ball gets there, okay, then we see the future ball moves many steps ahead. And for testing, we can also see exactly where we need to move our paddle, which is kind of useful. But now we can see that the future ball is accurately predicting the location that the paddle needs to move to, and even as the game ball speeds up, that paddle is still going to exactly the right spot. Continuing on, one thing I don't particularly like with how the game functions right now is when the PC's paddle gets to whatever its target location is, it just kind of like stops there. So say the target's right there. It just stops there well before the actual game ball gets to where it's supposed to. And that seems a little unnatural or robotic to me. And to make it just seem a little more natural, when it gets to this position, whatever it is, I want the paddle to kind of oscillate some certain amount up or down. And hopefully that will make it seem a bit more like the PC is thinking. We could even randomize that amount that it goes up or down, so it's like a little higher, a little lower each time, and that might make it feel even more realistic. Plus, if it's oscillating, that adds kind of like a level of randomness to the ball's position. So, or it makes it so that the PC paddle might miss. So say that the ball set to strike right here, but the paddle is oscillating and the paddle is up here for that second, and the ball just happens to miss. That might not be the best example because the paddle would appear to be moving away from where the ball is supposed to go, but it would make it possible for the PC to miss. And that's something that's currently not possible. There's another way we're going to look at that in a minute, but for now, let's just focus on making that PC paddle oscillate up and down. Before we start having it oscillate, we need to put some code in here to figure out or to determine if the PC's paddle has gotten to the location it's supposed to. So rather than having it move towards the detected collide Y every single time, once it gets to this point, what we want it to do is to actually start oscillating. Let's say we have our PC paddle there, and we have the target, which is right there. So it got to the target. Let's say that target is at the point 201. So that's where we have determined that with the future ball, we've determined that it's going to collide right there. So at y equals 201. Now let's say remember that the paddle itself, currently the speed of the paddle is equal to 3. So it can only go up or down by 3 spots at a time. It can't move in increments of 1. That means it's possible that the PC paddle has like a Y, let's say center. So we know the Y is up there, but we have to calculate the center Y. So let's say the center Y of that paddle is at 200. Well, that's definitely close enough to 201. We would want to start oscillating there, but we can't say center Y is equal to 2 or to Y because of that discrepancy with the speed. So what we actually want to do is calculate if the center Y is very close to the target. We don't want to calculate if it's actually equal to the target. The easiest way to do that is to just take the difference between the center Y and Y. So center Y minus Y, the difference. We take the absolute value of that and we see if that's less than whatever the tolerance is. And in this case, our tolerance is going to be the speed. So I'm just going to make it 3, I think. But if we're within 3 pixels of where we're supposed to be, then we're going to consider that as being on target. And that's the point we're looking for to start oscillating. Let's do this after we get to, or after we're moving. So we move the paddles, and now let's see if we're close to target. And in order to do that, I'm just going to do an if math dot absolute value, math dot abs of um, the detected Y collision point minus the paddle's center Y position, and I don't think we put I didn't put a get center Y in here yet. So under the paddle class 2, we need to make a method that says get center Y, and this is going to return the center position of that paddle. So return the Y position of the paddle. Oops, your return, return Y plus the height of this paddle divided by 2. And that gives us our center position of the paddle. So if the detected collision point minus the PC paddles back in Pong game, center Y, and if that is less than our tolerance of, I'll say 4. So if it's within 4 pixels of where it's supposed to be, then at this point we need to start oscillating. And once we do get to this point where we are kind of within range of where we're supposed to be, we should have another way to kind of keep track of that so we don't keep moving towards this detected collide Y position. Let's go back to the top and create a new instance variable under the Pong game class again. It's going to be a private boolean got to target. And initially, got to target under the constructor is going to be false since we didn't get to our target location yet. And again, we're going to want to reset that target every time that we reset the game. So every time someone loses, we need to reset that. But we also need to reset it every time it actually bounces off the right side or the PC paddle. So where we reset the future ball here under the collision detection and game logic with the PC paddle, we need to set it to false there as well. Then finally, when we get to the point where we want to start oscillating, we set this to true. Now I can wrap this PC paddle, move towards detected collide Y. So if not got to target, so if we have not got to the target location, then we move towards that detected collision point. And otherwise, that means that we have gotten to our target, so we can put an else in here. And this is where we want to actually start oscillate up or down. And I put a C, don't know why I got a C in there. Anyways, we've determined that we have gotten to the target location. Now we want to start the oscillation. Okay, let's talk about how I want to handle this actual like oscillating up and down. So right now we have gotten to our target, or at least we're in range. So got to target is currently true. And once we're here, we want to move up or down by a certain amount. And I'm just going to have it move by a maximum of like 10 spaces up or down. It's going to oscillate 10 pixels up. And then once it gets to this point, we're going to go back down until it's 10 pixels below where it started. Now, the easiest way to do this, I think, would be to, let's just break this down. So we got to target, and we want to basically change the position we are moving towards. So we have moved towards, right? And I think I'm just going to have it say, like, we're going to have the PC paddle, we're going to want it to move towards 0. So that'll make it move up. And then once we get to that certain point, that is negative 5 or 10 pixels below where our target was. So negative, or so it'll be our target minus 10. So target Y position minus 10. Once we get there, then we start reversing and we go back up until we get to our target position plus 10. And then we just go back and forth until we reset and find the next future ball and everything happens there. So for oscillation, we get to our target minus 10, we get to our target plus 10. We're going to need another variable to basically just keep track of our which direction we're oscillating towards. And I think so we oscillate to 0 there, and I think for going up, I can just check if we oscillate towards the height of the window, because that's going to be like the maximum position we're going to want to go anyway. That doesn't make a ton of sense yet. Maybe it will make more sense when I actually put this into code. So I need a target like oscillation variable here. So I'm going to make another private integer and oscillate towards. And this is going to be either 0 or the height of the window. And that's the direction I'm currently oscillating like up or down towards. Basically, this is like how we track if we're going up or down with the oscillation. Oscillate towards is currently 0. We'll start it there. We actually don't need to reset this because it'll kind of like, it doesn't matter which direction it's going unless you want it to oscillate in a certain direction each time. But I'm going to have it just continue from where it was, so we don't actually need to reset that other than the initial time when we set it in the constructor. Okay, so oscillate up or down. So we got to the target. If the current position of the, so if PC paddles, if the center gets center Y, so if the center Y position of the PC paddle is less than the target position, so we haven't changed anything with the target collide Y, minus 10. So that means we have gotten down. So Y is going down, which means the paddle's going up. So if the paddle's going up and it's gone more than 10 pixels, it's moved more than 10 pixels, we want to set our oscillate towards variable to be equal to the height of the entire window. So we start oscillating down towards whatever the Y variable is, that is the window's height. Else, if the PC paddle gets center Y is greater than the detected Y collision point plus 10, Then I'm gonna oscillate towards 0, so it starts oscillating back up again. Then finally in here, I'm just going to do PC paddle, move towards whatever position we are oscillating towards. Okay. And I think that is it. Let's see if that works. I run the program. We see that the paddle got to where it's supposed to, and it did look like it was kind of jiggling up and down there. And yes, we can see here it is oscillating up and down like I wanted it to. So the oscillation logic there did in fact work. There are two more things I wanted to cover before we get to the end of this video. And the first is this issue that we have with when the ball comes in at like a 45-degree angle from the top there. You might have noticed that if it does that, if it comes in from the top or the bottom of the paddle, the ball just kind of bounces around inside of the paddle and then shoots out one of the sides. And that happens because of an issue with the collision logic and the movement of the ball. But basically, when it comes in from the top or the bottom, it can get stuck inside of the paddle, and it does just like what it looked like it did. It basically just zigzags back and forth inside of the paddle. The easiest way, I think, to resolve this issue is to return to where we check these collisions, and it can happen on the PC paddle as well. But where we reverse the X, right after we do that, I'm just going to kind of nudge the game ball, nudge ball outside the paddle. So we're going to basically force the ball outside of the paddle if it somehow got stuck inside. Game ball, do I have a set X yet? I don't think I do. So we need to create a setter for the ball class to set the X outside the class. So public void set X integer X. Then this X equals X. All right. So the game ball, we reverse the direction, and now we do game ball dot set X is going to be equal to the user's paddle get X plus the width of the paddle plus 1. And that will nudge it just beyond the right side of the paddle. Depending on what angle the ball comes in from, this might look a little odd, but it will be better, I think, than having the ball actually just get stuck inside the paddle like it was before. And there we go. So it did not get stuck that time. Then we want to do the same thing, but opposite for the collisions with the PC paddle. Do that. Maybe I should do this right here. Do it after I reverse it. So nudge the game ball, set X to the PC's paddle, get X minus the width of the ball minus 1, so minus 11, I think. And remember in the last section where we calculated the positioning of the paddles for the collision logic on the PC paddle. With the PC paddle, remember it starts in the upper left every time, and the ball also starts in the upper left. So we detected actually if the collision point was kind of like outside of the PC paddle. So I'm checking for collision with this point here because that's when it actually looks like it's hitting the ball. And that's why I subtracted by 11 there, because the width of the ball is 10 minus 1. And then we have our X position there. So that should nudge it just outside of the left side of the PC paddle. And then there's no need to reset future ball, because when I did that there, I just made a new ball. I think the future ball might not perfectly line up here after if we have to nudge it with the game ball. I'm not really gonna worry about that because it's only gonna be off by like a tiny amount. Continuing on, the next piece of kit I wanted to work on is making it so the PC can actually lose like on purpose. After every certain amount of bounces, I want the PC to have a chance of missing the next shot. Because otherwise it's not going to be fun if the user can't possibly score on the PC. I'll close that and let's randomize the PC's losing. What I want to start off with is yet another boolean at the top of the Pong game class. So we have private bool, and it's going to be PC accidental miss. And if this is true, then the PC is accidentally going to miss the next shot or the next bounce. And in the constructor, I set PC accidental miss to false because I don't want it to miss initially. And I had to set that to false again every time that we reset. So find the reset method. And in there also set PC accidental miss to false. Finally, with this, we need to figure out where we're going to actually set this to true. There's a few different places where we could do this, but I think I'm going to make it so there's a random chance of that turning to true every time that the ball collides with the PC paddle. So it collides with the PC paddle on the right, then there's like a, I don't know, a 33% chance or whatever chance you want to be for that to miss on the next time it comes around. So the user then has to intercept it, and then after that time, once it goes back to the right again, the PC intentionally misses. Let's handle that here. So let's say the PC has a 50-50 chance of missing the next. And we would probably want to make this a bit like lower, or you could even have difficulty settings that changes this miss percentage. But for testing purposes, I'm going to just make it 50-50. The easiest way to do a 50-50 chance in Java here is to use this trick here, and it just we're casting it to an integer math.random times the 1 and 2 in this case. If we wanted 1 and 3, would make that a 3, but I'm doing 2 for now, and it equals 0. So this is basically saying there's a 50-50 chance. And if you want to see how that logic works, I will demonstrate this real quick with a calculator. So math.random produces a random number between 0 and 1. It can be any decimal value between 0 and 1. So let's say that math.random produces 0.22, right? Well, we could do 0.22. Okay, if I multiply that by 2, we get 0.44. When I cast that to an integer, it's a 0, and then the condition goes forward. Now what happens if I do something that's higher than 0.22? Let's do like 0.51. So if I get above that 50% mark, and then you should know 0.51 times 2, well, that's 1.02. In this case, when I use this when I cast it into an int, this becomes a 1, and then this condition is not true. That's where that 50-50 comes in from, because there is a 50% chance that any number below or any number between 1 and 0 is going to be below 0.5 or above 0.5. The same would be true with like 0.33. So if I wanted there to be a 0.33 chance of something happening, and I make this math.random times 3 instead of times 2, now any decimal value above 0.33 times 3 is going to return 1. Anything below 0.33 is like, or even 33 itself times 3, it's going to return 0 there when we cast it into an int. If that is not making a lot of sense to you, you could also do if math.random is less than like 0.5. That's not exactly a 50-50 chance, I don't think, It's like slightly off, but that would effectively be almost the same exact thing. And you can even do like 0.33 if you wanted to be 1 in 3. But I think this is the most accurate way we could actually get close to like a 1 in 3 chance. I'm gonna do it with 1 in 2 for now. And if that is satisfied, we set PC accidental miss to true. And I'm just going to do a systemout.println for testing. PC should miss next time. Finally, we need to implement some type of logic to actually make the PC intentionally accidentally miss the PC accidental miss. And this is going to be, of course, also, it should also probably be in game logic somewhere. Where do I want to implement this? I think the best spot to do this would be where we actually find that detected collide Y position. So here's where I found that. And that's ultimately, remember, what we're moving towards. So if I just change this by a certain amount, that's going to make it miss, right? So after I find the detected Y collision point, and we're supposed to miss the next time, all I have to do is offset that by a certain number. I could make it positive 100, negative 100. I could make it a random number between two numbers. That would probably be, I mean, a better way to do it. But for testing, let's just do plus 100. And if I run that, now it collided and okay, so I did not see anything in the console saying it's going to miss the next time. So that time the 50-50 chance must have um, not set that accidental miss to true, so that means it should collide again, and it does. And I'm just going to I'm going to skip ahead a little bit here until we get to one where the 50-50 is actually true. Oh, never mind, there we go. PC should miss the next time, so I hit it. And now since I incremented it by 100, it is 100 pixels off from where it should have been, and I was able to score on the PC. That did not look perfect, but I think it is, in general, an improvement to the way we handle the logic for everything and make the game just slightly more fun. In the next video, if we take a look at our game logic method, it's getting quite long. There's a fair amount of different things going on in this one method. In the next video, I'm just going to work on kind of breaking this down and condensing it into more bite-sized chunks. I probably should have done that. Well, I definitely should have done that just to kind of start off with this actually, but you know, ADHD and whatnot. This program, as it's getting more complex, and if we're gonna keep adding more features to it, we don't want to just keep cramming a bunch of random logic into this one method because that is getting a little disorganized. Anyways, I hope you found this video helpful. If you did, feel free to leave me a tip or check out my website, subscribe, all that good stuff. And I hope to see you in the next one. Also, I just remembered I forgot to get rid of the future ball from the paint component method. So if you want to turn the future ball or the prediction ball back to invisible, just delete the future ball.paint statement from the paint component method. All right, bye.